All right. Now, when do you use integration by parts? You use integration by parts the same way that you use the product rule with derivatives. When do you use the product rule with derivatives? When they're being multiplied. So when you have two terms being multiplied, you need to write that down, because a lot of people don't realize when you actually need integration by parts. You use integration by parts when you're multiplying terms and you need to integrate. So, integration by parts. Now, I will test you on this. I'm just not going to test you like I would in 141. But integration by parts, and this is kind of an intro for 141. Used when multiplying terms and integration. Now, sometimes you can use algebra. You know, like if I tell you to integrate x times x plus 1 dx. Now, if you have x times x plus 1 dx, what can you do? You can distribute and then use your algebra. So, and with the rule of integration, you get x to the third over 3 plus x squared over 2 plus c. That is not what we're talking about. Although you could use integration by parts. But just to give you an example of integration by parts where you can't use algebra, it would be x squared times the natural log of x. Now, can you use algebra with that? No. So you might want to put a little no algebra. In other words, you have two terms that you're multiplying, but you can't multiply them together with algebra, so you just say cannot be done. No, you put integration by parts. Ultraviolet minus voodoo. What? Ultraviolet minus voodoo. Ultraviolet minus voodoo. I don't know how to spell voodoo. I guess I watched too many movies, but I sure don't know how to spell it. Ultraviolet minus voodoo. Now, that's kind of like first times derivative second plus second times derivative first, or first times derivative of the, what did I say? I'm sorry. First times derivative of the second plus the second times derivative of the first, or denominator times numerator squared minus numerator times denominator squared over denominator prime over denominator squared. It's just a way that you can what? Learn it. Now, it doesn't matter how you do it, okay? But sometimes it's easier if you pick what's easier to take the derivative of, all right? For example, here, I probably would pick, I make b equal to x squared and u equal to the natural log of x. Why? Because it's easier to take the derivative of the natural log of x. That's why. Now, if you want to go through and do the antiderivative of the natural log of x, knock yourself out. But in cases where you have a natural log, chances are u needs to be the natural log. Does he see anything
yet? Yeah, this is all right. I get Skype running on my laptop, but let's see if they can do it. Maybe I'll do it. That's what he's trying to do.
Okay.
Phone app's gonna work anyway.
All right, well, tell him to text when he gets on, because unless he's got a mic, I'm not going to be able to know because I've got everything hidden. All right, so here I'm going to make, and I'm just going to clear this screen. Antiderivative of x squared times the natural log of x dx and ultraviolet minus voodoo. So I'm going to make u equal natural log of x. And I'm going to make v equal the other one. Now the arrows I give you so it'll help you out. Not that I'm trying to help you pass or anything. Well, my job is to have a 17% retention rate. All right, so well, if I'm giving you, what am I going to do? Okay, I heard. Take the derivative. If you're giving u, you're going to take the derivative, which is called du. So what's the derivative? Now the blue is supposed to be the opposite of the red. So if I take the derivative of u, what am I going to take the blank of v? The antiderivative, and that's going to be what? dv is equal to what? Or, I'm sorry, dv here. And this is v, sorry. Mistake. Sometimes when you're doing antiderivatives and derivatives, you get kind of mixed up. dv is x squared, and what is v? And now what do you think you're going to do with all that? Thank you. No, I forgot that. Don't forget this. Couldn't forget the two X's. All right, go to it. I went and bought trick-or-treat candy last night and got me a bag of Almond Joys. Nobody likes Almond Joys when you're a kid, so this is a grown-up. Yeah. I would give everybody one, but I only got like 5 in here, so if you want one, you can come get one, okay? But there's only like 4 or 5, so there. You want one. I know everybody's hungry. So you ain't had no breakfast. I know I haven't. Because my son and I get up at 8 o'clock. Did he say he's on yet? All right, so ultraviolet minus voodoo. U is the natural log of x. V is x cubed over 3 minus the antiderivative of voodoo, which is x cubed over 3 times 1 over x dx. Okay, so this does nothing. You could do 1/3 x cubed natural log of x, or you could keep it over 3, it doesn't matter, minus, well, what happens here? You get x squared over what? Or 1/3 antiderivative of x squared dx. You ever get a big piece of steak and there's a lot of fat and gristle on it? Okay, some people like that. Not the gristle, but the fat. Okay? But if you don't like that, what do? Throw away the whole piece of steak? No, you cut around it and you cut the gristle out, and what's left is what? Good stuff. What did I just do? I cut out all the stuff, and now I can take the antiderivative of what's left. That's what you're doing. Okay? Now, it helps to do this because sometimes, especially with trigonometric functions, you're going to have to use the integration by parts because you can't do anything with sine times cosine. You can't multiply it together. So the integration by parts is mainly for a lot of trigonometric values, which you're going to see a lot of in Calc 3. Okay? So we finish up. Golly, this is hard. X cubed natural log of x minus 1/3 x cubed over what? Plus c. Don't forget to add the plus c. And then that comes out to be, now you could factor out the 1/3, and that way it'd be out front. You could do that. You could multiply the 1/3 times the x cubed, but I'm not going to worry too much about that. I'm just going to write that as the answer. And you could simplify it more if you need to. Question. Ultraviolet minus voodoo. So right now, there's 3 things that you need to be able to do by integration. 1 is to do basic integration. 2 is to do integration by substitution. And 3, do integration by parts. Okay? Now here's one that teachers love to put on tests because it confuses the heck out of students. Okay? And they tell you to use integration by parts. The antiderivative, the natural log of x dx. Now I want you to see if you can set it up, because there is 2 parts there. So go ahead and try. What's the most complicated part? No sneezing. You don't get almond joy for that. All right. Probably allergic to almonds, aren't you? What is the most complicated part? Well, which is the most complicated part? There's 2 parts there. Which is the most complicated? No. There's 2 parts there. Huh? Natural log. So you're going to make u equal what? Natural log x. The other part, you're going to make dv. You're going to take the other. May have to add something to it, but you're just going to sit there and stare at it unless you add that part to it. There's one thing that you could add to the problem, and it's there, but you just can't see it. Not 1 over x, but what's in front of the dx? 1. So you got 2 parts. Natural log of x and 1 dx. Don't ask me why teachers love to put this on tests. And if they did put, I don't know if they do or not. I know they don't do it on the SAT very much. They put some pre-calculus, but they're not going to put integration by parts on the SAT. But if they did put integration by parts on a standardized test, this is the question they would put up. Because this is the problem that students just sit there and what? Stare at it. My son was Thor. Which he don't have blonde hair, he has black hair. But And I went and buy a $20 wig. At Party City, a wig for Thor was $20. I said, no.
My daughter cried the whole time we were in the conference. She's 3.
That's why.
She was tired too.
Well, he was tired. We only went to like 10 houses that we knew. I didn't take him to no stranger's house, giving cocaine or anything. So we went 10 people that, we knew. And they do the Halloween. See, I'm the anti-Halloween parent. They're the pro-Halloween parent. They got a picnic table out in the front yard with lights all over it and big old bags of candy, and they're dressed up, and I'm like, y'all are weird. But the only time I get festive is Christmas. That's it. I grew up with a very non-festive family. Well, farmers. Farmers are not very festive.
We got time for that.
Yeah, it's true. Ain't nobody got time for that.
Is he on here? He says that he's available.
All right, well, let me see.
If not, I'm sending him a screenshot.
When should you get ready for Skype? Right before class or 24 hours before class? It might help you get ready for Skype 24 hours before class. All right, let's see if he's on. Nope, says offline. See that? Everybody look. What does that say?
Is he not using Skype for business or something?
No, that's it. Tell them to use Skype for business. Skype for business is the only one that you can do recordings. Skype, you can only see each other. That's why it's called Skype for business.
Which is the 365 at the school.
Everybody's got it. Did I show y'all the last week class?
Yes, we do.
Okay, well, I'm gonna put it. No, it's probably still not on here. No, because somebody logged out. Somebody, what did he do it? Restarted the computer. Well, I've already showed y'all that, so y'all got it in real quick. All right, so which one's you? Natural log of X, Hubert. That's right. Which is DV, or, sorry, yeah, DV. Which one's DV? One what? DX. All right. So, what is the antiderivative of natural log? 1 over x dx. And what is the antiderivative of 1 dx? All right, plug each other. You see why they put it on a standardized test, or they like putting it on the test? Because it's so what? Difficult or so easy? So easy. Ultraviolet minus blue. Natural log of x times x minus antiderivative of x 1 over x dx. Natural log of x minus, what happens to the x's? And you're left with the antiderivative of dx. So your final answer is x, natural log of x, minus what? You say antiderivative of dx. We get to C. And you can also factor out the x. How hard is that? It's not hard, Hubert. No, it's not hard. If you can't do it, you just suck. X squared sine of x. Antiderivative, x squared sine of x dx. All right, I'm going to let you do that. I would let u equal x squared.
That's all watch over him, though. He's.
He hasn't got it on. He hasn't got.
I think he's. I don't know. He's just. I told him he said, well, I have the free Skype or
No. Tell him to get Skype for business.
I did. I sent it on my phone. So
Okay. Did you send him the portal?
I sent him a picture of my Skype, a screenshot of my Skype for business.
Okay.
And whatever it was that I said, that you need to download that. And it's free.
Yeah.
It's coming up free. It's
Yeah.
free for the download.
Yeah, he has to go to his portal. What's it called? Outlook portal?
I didn't do that. I looked online. It says Skype for business for download.
Okay.
If you look at a couple places where you kind of find it, you download it and then when it asks you to sign in, you use your TCTC sign in, of course.
Office. Is it Office portal? It's Office portal. See, if Tri-County Tech would get on the ball, we could have calculus classes that meet here and Evesley campus and Pendleton campus. Because we can do it via Skype, or we can do it via, we have three students in the class at Pendleton, 3 students at Easley, and 4 students at Anderson campus. That would be how many students?
6. No.
9. Instead of 3 at Anderson campus, or 3 at Pendleton campus, or 3, it could be 9, and everybody use Skype.
Do they satellite churches like they do satellite campuses?
Yeah, Tri-County Tech do so. That's basically it. We still got people that write emails in the subject line, so they don't know how to use email. But we're a technical college. Technical, what derives off of technical? Technology. But we got teachers who don't even know how to use the whiteboard. Because we haven't had training. All done already? Am I that good of a teacher? I must be just fantastic. Fixing to send a smart aleck email. President.
Yeah. Auto. Good.
Thanks. What is it called when you have video? Huh? Collaborative. Sounds good to me. What? What did you say?
Video conference / video classes.
Video conference / video classes. He knows what I'm talking about. He knows me. There. Sorry about that. You ever have one of those moments when you just got to get on a soapbox? I guess y'all don't.
That probably would have been a lot longer.
Well, I didn't want the one person that's going to complain. I didn't want them to go complain this morning, so. And I can't find where I was. Where was I? Okay, here we go. So, you're not allowed to do that. That's Tri-County takes electricity. You don't pay that in your tuition.
Oh, yeah.
No, you don't. There's not an electrical service fee. Okay, what did I say I was going to make you? You can make you anything you want, but I'm going to make you equal to x squared. Therefore, du is equal to what? 2x dx. And I'm going to make dv equal sine of x dx. And what's the antiderivative of the sine? The negative what? Cosine of x. Now, you could easily make sine of x, and then you could do it both ways. You're going to get the same answer. We'll try to do that the next problem, do it the other way. So, ultraviolet minus voodoo. Now, just so you know, over here, what can I pull out of this guy? What can I pull out of the integration? I can pull this negative out, which will make this a what? A positive Hubert. And I can pull what? This 2 out. I'm going to go right there. So, that would make it negative x squared cosine of x plus 2 antiderivative of x cosine of x dx. Oh my goodness, what do we got? Yes. That's just what the antiderivative sign of x is, I thought. I think that's right. I think somebody looked it up. Huh? You say about the derivative?
Yeah.
Yeah.
So where do we get the negative x squared in the very beginning? Is that because of the cosine? Okay.
I brought this negative right here. Oops, hold on. That negative right there, I brought out here. Yeah. Okay, now what do we got here? Integration by parts, Hubert. Yes. We got a nested problem. We got integration by parts inside integration by parts. So that means you have to what? Quit. So finish it. Said try one more time. No. I think you gave up.
Yeah, because the spectrum is this, both times I know it to the new
Mm-hmm. Okay, so what we got? We got negative x cosine of x plus 2, and then we got, and I'm just gonna put a big bracket here, and then we're gonna put u equal to x, du is equal to what? Dx, and we can make dv equal cosine. And what's the antiderivative of cosine? I think it's the sine. Let me make sure. Yeah. And if you want to, and remember, when I did go over the integration of trigonometric functions, all you have to do is Google it. Google integrals or antiderivatives of trigonometric functions, and it'll give you the list, just like the derivatives of the trigonometric functions. It's not mathematical, it's what? Memorization. So all you need is the list. So you should be able to do that. Let me show you how long it takes. At least takes 2 or 3 days. You have to go to Google, and that takes a while to go into Google. Or you can just not go to Google. Yep. Like I said, it's real. I can't even spell it. I went to those dadgum porn sites. Okay, how do I get rid of this? I have to what? Where is it?
McClure.
I can't see if I do it. I can't see what y'all are. Thank you. Yes. Yeah. Oh, well, my credit card details are all over this computer. I buy stuff. I'm a teacher. You can think. Can't think of it. There comes a guy talking.
I don't even know.
It's all because of Wiener. This is Wiener's emails. This is Trump's way of distracting the American public.
It's just gonna keep reopening. Start over.
I don't want to start this whole thing over. Try that.
Shut the computer off.
Yeah, see, it just keeps reopening. There's a batch file just running.
It keeps reopening, y'all.
You have to shut the computer.
I don't want to do that.
Oh, there it went.
Okay, thank you. I don't understand how I got it called up. Where is Google? I'll just go straight to Google. I'm trying to show y'all something. I don't know. I must have went to a porn site or something.
You put www.ggo.
Well, that's like pulling up whitehouse.com. Don't do that. You ever done that? Don't do it. Antiderivative. Derivative. Antiderivative of trig functions. It's not supposed to take this long. I was being facetious. And there they are. Antiderivative of sine is negative cosine. Antiderivative of cosine is sine. So check, make sure I got it right. There's your 6 trigonometric functions. So you need to write them down and then memorize them. They're not mathematical. You don't have to calculate it. You just have to write it down. I thought I told y'all that when we went into antiderivatives. Maybe I did, and y'all just didn't what? Didn't go to Google because it takes 2 or 3 days, and then you have to print it out, and that takes another 2 or 3 days. So I'm sorry I make y'all do so much work. All right, so we checked that, so everything's good. Now that you know the integration of trigonometric functions, now that confuses the derivatives. Now when the derivative of sine is negative cosine. That's what you're going to try to do. So you need to take an index card, and you need to put the derivatives on the front of the index card, and you need to put the antiderivatives on the back. And you have to learn sine and cosine verbatim, because you're going to forget, and it's going to cost you on the test. Because I do it in Calc 2. I'll do the antiderivative of the cosine is negative sine, or I'll do the antiderivative of sine is negative cosine. I get them mixed up. And I've been doing this for I don't know how long. So if I've been doing it for I don't know how long, and you've been doing it for 1 year, chances are you're going to do it too. So you need to get sine and cosine down pat, because you're going to see sine and cosine 90% more than you're going to see the other ones. Okay? All right, so that's my little trick of the day. And while I'm on announcements, Thursday, I've got to be a chaperone for my little boy, so we will not have class Thursday. But, in order for me not to cancel class, and not for you to have a sub that's going to totally lobotomize you, I will have a video, and I will go over several problems. I will put those several problems on the homework. It'll be a special homework called, what's Thursday? Somebody tell me what the date is Thursday. The 3rd? Okay. It'll be called 11-3 attendance homework. It'll be 3 problems. And for me to take attendance that day, you have to do that homework, and it'll only be, I'll make it due from 8 o'clock in the morning to 12 o'clock in the noon, okay? You see what I'm saying? So you have to go look at the video, to do the 3 problems.
And the video is
I will put it on YouTube. I will put it in your class. It'll be called 11.3 No Class Video. And I'll put it on YouTube. It'll be right after this video. And you look at the video, you write down the 3 problems or the several problems that I do, and then you'll see those 3, maybe 2 or 3 problems, and that'll be, if you do the homework, I'll make sure you have attendance for that day. If you don't do the homework, then you don't have attendance for that day. It'll be an absence. Okay? I have to make that deal with my boss. What happened was they had this Columbia field trip to the museum, and one of the male chaperones called yesterday and said that he was sick. And they only got 2 male chaperones. And I'm the only one that's signed up as a chaperone, that's a male, that has, what do you call it, background check? You gotta take them to the bathroom. Yeah. So I was the next one in line, so they called me, anyway, all right, so we good? Everybody good for Thursday? Tell all your friends that's in here. I'll send an email to everybody that nobody will look at, nobody will read, but at least if I put it on the video, at least people will know it. Well, the 2 people that watch the video, at least they'll know. All right, so go up here. So that's going to be negative x cosine of x plus 2, and then that's going to be ultraviolet, which will be x sine of x minus voodoo, which is minus sine of x dx. Look there, ain't that nice? All I got to do now is take the derivative of the sine. I mean the antiderivative of the sine, integral of the sine. And what is the integral of the sine? We did it over here. Thank you for your interaction, Mr. Fun Scales. 1 out of 20 people. Cosine of x plus 2 x sine of x plus what? Cosine of x plus c.
Is that first x supposed to be squared?
Where?
The negative x at the front?
Yes. Yeah, I just decided to drop it right here, just for the heck of it. Now you see why I wanted you to learn this, because it's kind of bad to show you integration and u substitution and then cut it off, and then next semester after the u substitution and the basic integration, after it has gotten cold, to throw integration by parts on you. See, so I think in this way you at least have a part. I'm going to do this one more problem. This one's going to be the antiderivative. Now this one, you will incorporate algebra in it, but not at the beginning. Okay? So this one is e to the x sine of x. E to the x sine of x, and this is a test question. E to the x sine of x. I would suggest using a whole page of notebook paper, and I would suggest writing small. I would make u equal sine of x. Of course, you could do either one, but You know you overslept when your breakfast consists of almond joy and tea.
You wanna get on your sheet on first?
No, I'll let you do that. I'm all about shakes when I get in the mood for it, but I have to.
I was barely on it 2 days
I
ago,
have-
like, you look better.
I have to do it. I don't know, maybe it's just me. I have to really turn myself on to do that. I have to. Either I do or I waste my money.
Yeah.
And believe you me, I've done enough shakes my life to know. Not the McDonald's shakes either. When I was in the Marine Corps, oh my gosh, big time. Drank like 6 or 8 shakes a day.
That all you drink?
Pretty much.
Try to get lean?
Everything. Trying to get everything when you're in the Marine Corps.
I don't understand why in the last time we had 2 values for BB, we had 2 estimates and then the BB value was.
Because when you at that part right here, remember, when do you use integration by parts? Is that it? Yeah.
Yeah.
When do you use integration by parts?
Oh, maybe that's DU. Okay, that's not bad.
Right here, multiplication. So you have to do right here integration by parts, and then when you do integration by parts, you still have another integration by parts right here. That's why you have to do it twice. Is that your question?
Yeah.
Now, if this was a 3, what would you do? Just bring the 3 out, and that'd be 6, and then you just take the derivative, the antiderivative cosine. But since you got something multiplied, just remember, when you have x squared times natural log of x, and you take the derivative, you have to use power rule, right? Well, with integration, this is the power rule of integration. When you multiply 2 terms, and you can't use algebra. That's why I showed you at the beginning, and a lot of teachers don't show this. They just say that, where is it? Right here. See, I could use integration by parts here, but I don't have to because I can use algebra. But here, you can't use algebra. And it's multiplication. So just think of integration by parts as the product rule or product rule. Product rule for integration. The product rule for integration. Now this one you can make u equal e to the x because the derivative of e to the x is, or you can make it the dv and the integral of e to the x is e to the x. So it really doesn't matter. It depends on what you want to take the derivative of. And in this case, I took the derivative of the sine, which is the what? Cosine. Now if you look at integration of trigonometric functions and derivatives, you see how easy it is to say, okay, the derivative of the sine is the negative cosine. It's very easy to do, so you need to write those down and you need to memorize them, especially sine and cosine. So I'm going to make u equal the sine of x. Therefore, du is equal to cosine of x. dv, that's dx. dv is equal to e to the x dx. And b is equal to e to the x. Ultraviolet minus voodoo. I'm gonna write it over here. So ultraviolet minus voodoo. What do we got here? Same thing. So e to the x sine of x minus, I'm gonna put right here, I'm gonna make u equal to the same thing. Let's see, what did I make u equal to? I just wanted to go with my notes here. Yeah, I make u equal cosine of x. U is equal to cosine of x. So what is the derivative of cosine of x? The what? Negative sine of x dx. dv is equal to e to the x. Gosh.
No, that's not right, it's not negative sign.
The derivative of cosine is negative sine. That's why you gotta have them.
I thought the derivative of sine was negative cosine.
That's the integral. The antiderivative. Case in point, you do get a mixed up. You do. I don't care how smart you think you are, you're gonna get a mixed up.
I was looking right here, is when you show you that picture, and it's in sine x dx. With negative cosine.
I'm taking the derivative right here. Remember, this is the derivative, and this is the what? Antiderivative. V is equal to e to the x. Alright, so I'm just going to rewrite everything. Antiderivative of e to the x sine of x dx is equal to e to the x sine of x minus, I'm going to do ultraviolet minus voodoo in brackets, cosine of x, e to the x, cosine of x, minus antiderivative of e to the x, negative sine of x dx. I'm going to rewrite this. E to the x sine of x dx is equal to e to the x sine of x. I'm going to distribute this negative, but first, what does this negative do? Comes out. So I'm going to take my red marker and I'm going to highlight this negative, which is going to come out and make this what? Positive. This is multiplication, remember? It's multiplication, not subtraction. So I'm going to bring it out. So I'll make that positive. But what is this negative going to do to each of these? Make it negative. So this blue, this negative, is going to make this negative and make this negative. So, ex sine of x, remember that negative goes there. So negative e to the x cosine of x minus ultraviolet minus voodoo. U is equal to the sine of x. Du is equal to what? Derivative of sine is what? Cosine of x. dv is equal to e to the x. V is equal to e to the x. It's dx. So we've got to do ultraviolet minus voodoo again. So we'll go down here. The antiderivative of e to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x. And then I'm going to take my minus again, and I'm going to put brackets here. Ultraviolet e to the x sine of x minus antiderivative of e to the x, what? Cosine of x. And now you can take, it's just going to keep going and keep going. Well, it is. I just didn't have enough room. Sorry. This cosine of x with the x. Sorry. I'm sorry. Don't forget to put the dx. There. That's what happens when I get to the right side. It starts erasing for some reason. All right, now, at this point, what I wanted to show you is, if you notice, what happens each time you do this? It just loops, right? Look right here. I'm going to rewrite this. I'm going to take my handy-dandy eraser, and you can do whatever you want to in your notes. But I'm going to stop right here. I'm going to erase this. You don't have to erase it. What you can do is just kind of mark this out. Because what I just showed you is we will continue, and you can do it forever, but you will always get the ultraviolet minus voodoo on the end. The voodoo is never going to what? It's never going to, it's always going to be e to the x times something. So you're going to do 15 pages of ultraviolet minus voodoo and not get what? An answer, Hubert. That's right, class. So I'm just going to rewrite this part right here with the negatives and all. I'm going to rewrite that. Minus e to the x. Let's make sure that's e to the x minus e to the x. And then I'm going to put minus antiderivative e to the x sine of x dx. Now, somebody look at that equation right here. Anybody see the algebra that we can use? No. 1 box of cereal plus 1 box of cereal equals what? 2 boxes of cereal. What? You can bring, do we have anything that's in common? Then we'll write something under here. Let's go back to algebra. What if you had a negative 2 square root of x plus 2 over there, and a 2 square root of x plus 2 over here? What could you do? What? Bring that over what? Here, and you have a what? 2. Positive 2. What is 2 square root of x plus 2 plus 2 square root of x plus 2? 4 square root of x plus 2, right? Okay, y'all, yes or no? Okay, remember that in pre-algebra, algebra 1? Doesn't matter what you got. If you got a negative 2 star over here, and you got a positive 2 star over here, you can bring it over, it'll be 4 star. 4x. 2x here, negative 2x here. Bring the negative 2x over, it's 4x. Same thing with the radical. Same thing with the what? The antiderivative. What's in front of this antiderivative? What's in front of this I'm sorry. What's in front of this antiderivative? The negative 1. What if I brought that over here? What would it do? Turn into a positive 1. And what is 1 antiderivative of blah plus 1 antiderivative of blah? 2 antiderivative of blah. E to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x. Now, What's our objective? Our objective is to find the antiderivative of each dx sine x dx, right? So if I solve for that, won't I have my antiderivative? So what I need to do, divide by what? Divide by 2, Hubert. So the antiderivative of all that trash is equal to now that's what's called an algebraic solution. You're used to doing it back in Algebra 1 and Algebra 2. So if I wanted to solve for the square root of x plus 2, I divide by 2 on both sides. That's not a test, that's a test question, I told you, but that's also a test question that any Algebra 2 teacher would put on an Algebra 2 test. Because they get you down to that loop part, and what do y'all do? What do students do? They just keep on going, and about a page and a half, the student goes, this is unsolvable. That's why. When you see a loop like that, the chances are you need to algebraically solve it. Meaning get what you want by itself, and that's what you get. Now, you can factor out e to the x over 2. I think you mentioned that already. Okay? Now, that is several problems. I don't know how many we do. 1, 2, 3, 4. And that's about all I wanted to cover today, because I just wanted you to get a feel. Now, how many questions will you get on the test? You'll probably get all 4 of these or something like all 4 of these. I'll give you 3 or 4 on the test. Now, something else I need to talk to you about. I think I want to split this up into an antiderivative test, and then I want to do volumes and areas under curves as a separate test. So what we might do is I think I might go over a review in the video for Thursday of all the different antiderivatives, the antiderivatives, the infinite, the definite, the infinite and definite with U substitution, and then I'll just do indefinite. I'll do indefinite with these. I'm not going to ask you to plug in stuff with these, but I might just do all indefinite. I don't know what I'm going to do yet. Okay, but Thursday will probably be a review over the 3 sections of antiderivatives: basic antiderivatives, U substitution, and integration by parts. And then I will give you a homework with 4 or 5, 2 or 3 of each of those, or 1 of each, and you do those 3 problems for attendance. Then next Tuesday, we will I'll probably load a test up between Thursday and Tuesday. Okay, everybody with me? And then we'll probably start the last section of the unit next Thursday, which will be area and volumes under curves, which will be your disk and your shells. Y'all know what those are? Okay, good. So y'all be discouraged and confused. Yes? Oh yeah, well, then we will have a test. It will be uploaded between Thursday and Thursday of next week. So between Thursday of next week and next Thursday, you'll see a test, and it'll be called basic antiderivative test or something like that. It'll cover the 3 sections, okay? So I won't see y'all in a week, all right? And when y'all come back Thursday of next week, we'll go start volumes and shells and all that good stuff.
So we don't do anything on Tuesday?
You don't come into class because I'm not going to be, no. Tuesday is election day.
Yes.
Yeah, we don't have class. We have faculty staff work day. I don't understand how we can have faculty staff work day when it's supposed to be a day off. That's why I wrote that. That's why I wrote that email.
Did you go to the events yet?
Nah, I'm gonna wait and do it the day of. Hold on, I'll get the roll. I did? I didn't take the roll, did I?